Hello everyone, welcome back to another video here at our channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students who has completed one of our courses, ROS Basics in 5 days. At the end of this course, you can take a project and you can present it, and this is actually implemented on a real robot. So that's what we're going to be seeing here today. Hello, Stefan, how are you?
Hello, I'm great. Thank
Great.
you.
I'm excited to see your project. So whenever you want, you can start sharing your screen and just explain us how you've accomplished the project.
Sure. Share the screen right now.
All right, we
Right.
can see your screen.
So this is the robot and the course. And I'll start the program. Right. And right now the robot is searching for the nearest wall. It's turning to it, uh, approaching to a set point, and then turning with the right side to the wall. Now it is following the wall at a certain set point. I also made a PD controller, proportional derivative, to
Nice.
go smoother.
Yeah, it does look smooth.
And I also could increase the speed of the robot with the help of the controller. Also, couldn't increase the speed very much because the publishing frequency couldn't allow me to find the starting point very nice.
I see.
Yes. And after a complete round, the robot will stop.
And how does it know that it has done a complete stop,
It
a complete lap, sorry?
memorizes the starting point and then compares with the current position.
Okay, great. That was really smooth and perfectly done.
Yes. Thank you.
Could you explain us just how you've accomplished this and the three main parts of this project, please?
Yeah, sure. I have a presentation. Is everything showing? Yeah, so the ROS2 basic Python. The three main objectives were to find the nearest wall and align the robot with it, which I've done by using a service. The second objective is to follow the wall while maintaining a constant distance. This was done by using a topic. And the third objective was to calculate the total distance and to check the position, to compare the current position with the starting point to know if it has done a complete lap. And this was done by using an action. For the first part, the service part, I made the program to find the nearest wall and turn the robot to face it. This was done by rotating the robot and knowing the minimum distance position. For safety reasons, the robot analyzes a range of 20 laser beams. After the robot is facing the wall, then it will move in a straight line until it reaches a set distance. Then it will turn to left until it has the right side to the facing the wall. The service response from the interface is a Boolean, and it says if the wall was found or not. Also, the service server has two threads, the wall finder service and the laser scan topic subscription. Uh, After that, the topic, the wall follower topic, um, I defined the set point. Like I said, I use the PD controller for tracking. This allows faster speed and smoother movement. And the node is subscribed to the scan topic. And it uses also the average of 10 laser beams from the right side. And for the third objective, done with the action, I calculated the travel distance using the odometry data. Uh, Also, like I said, the robot stops after a complete lap. The action feedback from the interface is the total distance traveled data and the straight line distance to the starting point. The action result is the movement path, all the points from the circuit. And also the action server has two threads for the odometry recording action and the odometry topic subscription. And that's it.
All right, cool. Thank you for the presentation. Nice applause for you. Really, really nice presentation, and especially the demo that we saw was really, really nice and smooth. So congratulations. I have a couple of questions for you, if that's okay.
Yeah, sure.
Yeah, so the first one is about the PD controller you mentioned. I really like that you implemented that, and it shows in the movement of the robot. So, um, if you could just tell us a little bit of, if I understood correctly, you only use the right side, 10 beams on the right side for that controller. Is that correct? Or do you also use the front uh, beam?
No, the front is set distance, defined distance. And when the front is approaching the wall, it will turn to the left because it knows that a corner will follow.
So at that point, it's like a set movement, and the controller
Yes,
kind
exactly.
of stops in that moment.
Yes,
Okay,
yes,
okay.
exactly.
Oh, nice. That's a nice way
And
to
the
do it.
PD controller works only for the straight lines.
Only for the straight lines. And what is so you're measuring an error probably that you want to minimize in there.
Yes,
What is
exactly.
the variable there? The
I uh, I calculate the distance from the, like you said, from the right side of the robot to the wall, and I made a set point.
So the set point
And
is the distance
yes,
to the wall. Okay, great, awesome. I love to see that a little bit of an extra to improve and to show what you can do in simple ROS 2 nodes
thank
here.
you.
And
I made the PD controller because the robot, the real robot, because in the simulation everything was perfect and was no problem, but the real robot without the PD controller was moving very, I don't know, wobbling
mm-hmm.
from left to right, and the starting point was not really reached every time.
Right.
And,
And that was actually my second question is why do you think that is at the moment of switching that that you were having those issues in the real robot? Why do you think that is?
please, could you repeat?
So you explained the issues you had that between the simulation and the real robot, right? So in the simulation, everything was working fine, and then the real robot, you came into the need to implement this. Why do you think that is? What was the difference between the simulation and the real robot?
Um, well, I saw a lot of differences to the LiDAR sensor.
Mm-hmm.
Um, in the first place, the beams uh, are have a different index in the real robot compared to the simulation, and I had to test and adjust the program, the algorithm for uh, real LiDAR. And I also saw that the wall, but it's a paper wall. It's not exactly straight,
Right.
and the robot
Yes.
will follow it, uh, even its errors.
Mm-hmm.
And this caused me also some troubles. But with PD, I made that I adjusted it to uh, follow, but not really follow all the errors in the paper wall. So it will go straight line.
Right. Okay. Awesome. I see. I see. Well, thank you. Thank you for answering my questions. And I just want to congratulate you again, Stefan. Really, really nicely done.
Thank you very much.
And let me just switch back to my screen here. And for everyone else that is watching, this is your opportunity to do what Stefan did here, and is to come and present a project on with everything that you've learned when you take one of our courses. So I invite everyone else to do the same, and we'll see you guys at the next video. Thank you, Stefan, and we'll see you next time. Bye bye.
Bye bye.
All right.